Welcome to all of you. A special welcome to Mr. Manjukiran Aital. He is from the Lekha Wireless Company, which I understand is located in JP Nagar, right?
Yes.
Of Bangalore. Mr. Aital is an industry veteran with over 18 years of extensive experience in wireless domain, and is actually participated in the evolution of wireless technologies from 2G to 5G all the way through. He is the senior director for protocol software at Wireless and has handled various roles from hands-on development to strategic management, and he therefore has invaluable insights into wireless technology and the associated market dynamics. So, Mr. Aital, welcome to this workshop, and we are eager to listen to you. Over to you.
Thank you. Thank you very much. I thank you for the introduction. So I'll get started right away. We are from Lekha Wireless. So Lekha Wireless is actually a 14-year-old company, and we primarily focus on wireless connectivity solutions, right? So we are a deep tech company, and so I will now give an overview of our telecom RAN products and a slight overview of our other wireless products, and then go into what we have been doing for 5G, for ORAN, and then what we are going to do in the future for maybe advanced 5G and 6G also, right? I'll just give you an overview. So this is our team. So we have a 15-member business and technology leadership team. It's quite a senior team with a lot of experience in the industry. So we have 300 plus engineers working here. So we have a couple of office spaces, but all of it is co-located here in Bangalore. And we have some advisors who advise us on strategy, finance, and engineering. So we have been in this industry for now close to 14 years, right? This November we will be 14. And right now we have developed a lot of our development products which are done completely in-house, right? We have started from scratch. Most of the solutions which you would hear about, it is all done by us. We have a hardware team, we have software teams, we have platform teams, and we have a GUI team, we have FPGA, we have fabrication. So all the things have, everything you can call it as all under the roof kind of company. So we have invested a lot of our time, money in R&D to build the next generation technology. So primarily what do? We address market segments. These are the market segments we try to address. One is private networks, one is a public network such as telecom, and then we focus on defense. So we are positioned in the top 2 Indian wireless communication technology company. Okay, so what are our focus areas? So primarily we have a private wireless network focus, where we work with the railways and public safety initiative, factory automation, mining. So these kind of sectors is what we target. And then we have a independent and a completely different defense portfolio, where we have our own wireless equipment which cater to various use cases in the defense field. For example, missile control or telemetry. Sometimes your UAV, UGV kind of autonomous vehicles. Then SDRs, where you can create a manet out of nodes, without any terrestrial backbone being there. So those kind of defense products are already we have developed over the past decade, and much of it is already deployed with the armed forces. Now coming to public network, so we work with telecom operators as well as rural ISP. So in rural areas where the cell sizes are large and penetration is not high, so we are working with the telecom operators to provide connectivity in that. So these are the high level 3 market segments which we work on. So now I'll directly go into the Lekha ORAN solution. Okay, So I think you guys are familiar with ORAN. So I'll just show this diagram, which is, I think, familiar to most people. So these are the various components of the ORAN system. So whatever you see with the green tick mark here, these are systems or components which Leica has built, and we have complete ownership on these components, and these are readily available and kind of in various phases of deployment. Okay, so whatever we you see as an X here, which is the Oak Cloud, so this is something we don't have, and we use some third-party open source softwares or something which is available to get that done. And whatever you see as an yellow hourglass here, so these are something which is either under development or something which is not ORAN compliant. For example, Leica also has a LTE Node B, but it is not ORAN compliant. We have not made it ready for NSA operations and all that. So similarly, the SMO, which we have to configure, orchestrate, and manage our network, we have a EMS, but that is now currently not ORAN compliant. And sometimes the ORAN spec also keeps evolving, and as and when we feel the necessity to make it compliant, we will be doing it. Okay, so this is the thing. So primarily on the radio access network, which we would call as RAN now, we have all the main components which are available. So the DU, the CU, CP, the CUUP, and the RU. So all these components are available at Leica, and all of it is built by us from scratch. So this is a overview of our CU and DU, which is primarily a software-based solution. Okay, so we have a software-based solution for CU, UP, CU, CP, and DU. So these are different software components. And in the DU also, we have two different components, one for the DU L2 and one for the DU L1. So all these components are well separated using standard interfaces. So these F1C, F1U, E1, these are interfaces which are actually prescribed by 3GPP. So 3GPP has already given clear specifications for this, and we are compliant to it. So what does it mean? You can actually take our CU, CP and use it with somebody else's DU or somebody else's CUP. So that is what it means. So there is no vendor lock-in, and it actually reduces the cost because you have a bigger pool of software components from where you can choose. It improves compatibility and also competitiveness that way. So these are all available, and yeah, the 5GC is actually the 5G core. We are not into the 5G core. We use some third-party 5G core. Whereas this interface which you see is actually the 7.2 front haul interface. So this is something which is not a 3GPP interface, but it is defined by ORAN. So ORAN is another organization, right? So we have a Leica RU which is compatible to 7.2 interface, and our DU is also compatible. So how does this work is we have integrated our CU-DU solution with third-party RUs, as well as we have taken our RU and sold it as a standalone component or standalone product to companies which have their own CU-DU solution. Okay, so much of our system. So we'll get to the how it is made. So our CU-DU solution, when we moved from LTE, for example, in LTE we had a hardware which was very specific to our our product. So now we don't have that. We have a generic hardware which is basically commercially off the shelf available. So this is just what we use mostly, Dell PowerEdge and all that, but we are not limited to Dell. So you can use any from any vendor. You can use the thing as long as it is x86 or ARM based process. We can actually make a deployment on it. So the hardware is agnostic. We don't really mind the hardware. There are certain minimum specifications which are required. As long as it is met, we can deploy our CU-DU software components on that. Okay, so these are some of the components which we use, and yeah. So one of the other thing is, when we are running our DU, that DU can cater to up to 3 RUs. So 3 radio units can cater. So if you want to put a 3-sector cell, a single DU instance can take care of those 3 sectors. and a CU can cater to 3 DUs. So a single central unit can actually control 3 distributed units, and in effect it can control 9 RUs. So that is 9 cells can be deployed with a single CU, and 3 cells per DU. Okay, so that's the architecture. So go next. So this is again about our RU unit. So this is the, see, as a radio unit, we have many variants of it. These variants vary in terms of their capacity as well as their cost and their form factor, right? So we have an indoor small cell 44R. Its capacity is 250 milliwatt per antenna. So it's a very small factor. Basically, you can put it in the same place where you were putting a Wi-Fi router earlier, inside your office premises or wherever. You can put this unit and can get better 5G indoor coverage with that. And because the power is also less, it's actually not going to affect any environmental thing. So then we have outdoor unit, which is mid power, and then we have outdoor high power unit. So these are the units, actual pictures which you see. And for this, the hardware and the software, the firmware, everything is done by Leica in-house. So we have 2x2, 4x4, and 8x8. These are actually the number of antennas which are available. Okay. So primarily we are having N28 and N78 RUs, but the baseband can work with any of these things. So we can also build, based on deployments or whatever requirements are there, we can build for other bands as well. Okay, so this is a topology diagram of how our system would look like. So you can see that most of our system, so these are actually your generic 1U or 2U rack servers. So our entire software runs in this. So you can actually see that the core, the server, any kind of applications, right? They run on something behind the core. So this is again logical. So all of this actually can be put on a single server with virtualization, or if you want to separate using a virtual software, a pod, which is like Kubernetes pod, so you can do that. So the Leica CUDU also can run on the same server or maybe on another server. This is a carrier network. Basically, this is the backhaul, and this is the front haul, 7.2 interface. Okay, so apart from that, there can be a mid haul where you run your CU and DU at different geographical locations. So yeah, this is just about our how our infrastructure looks like, and we have various use cases which we can readily demonstrate. So why we have such use cases is primarily to show the capabilities of 5G. So 5G, if you want to show a 5G, so right now it's written as a VoIP call and IP camera and all that, which is kind of existent, let's say, even in 4G. But when it comes to 5G, you can actually go for high HD videos. You can go for an IP camera, which is HD, and we can do some real-time analytics. So these are possible because of the higher data rates and the lower latency. Okay, so yeah, so this is what I explained. Up to 3 CU and DU instances per 100 MHz carrier can be put on the single server. Okay, so that is this thing. Okay, so then coming to our compact solution. So apart from these solutions which we have, which are server based and ORAN compliant, we also have a compact 5G RAN solution. So these are units which may not be strictly ORAN compliant. Everything is actually bundled together, but it actually has the same functionality. Functionality would not change. Maybe there would be some reduced functionalities in some case. For example, you may not be able to do 100 megahertz with the reduced form factor. You may be able to do 20 megahertz, but that should be sufficient for many use cases, right? So the advantage with the smaller form factor is that you can actually reduce on infrastructure cost. So wherever you have to maybe draw power cables or optical fiber, that may not be required. So then we also have a 5G NIB for network in a box. So this is a completely self-contained solution with the core network, which is the 5GC and the RAN, which everything is inbuilt. So these are portable units. So with those, because of the small form factor, and because they really don't require any backhaul connectivity in some cases, they are portable. So it can be used for rapid deployment. For example, event-based deployments. So what are event-based deployments? See, whenever there is a natural disaster or whenever you want temporary network at a location, where there is none or there is something which is like there's a public network, maybe you don't want to use that. You want dedicated resources, good QoS. So such kind of things, you can put a temporary system or event-based system. And these kind of deployments, it will offer flexibility. Small form factor NIB can offer flexibility. Okay, so that is the thing. And then so coming to our EMS, so I was showing you the ORAN SMO, which is not, I was saying, not completely ORAN compliant. So we have ORAN SMO, which supports netconf and yarn. So this is the recommended ORAN specification. Netconf is the ORAN recommended transport mechanism for configurations. So we really do that, but this is primarily built for controlling our 5G network elements such as the CU, DU, RU, and all that. So maybe it may not be completely ORAN compliant to control any sort of ORAN device, but yeah, it kind of we derive from the ORAN spec and have implemented it. So this is actually a screenshot of our EMS GUI. So the EMS, you can actually add different sites here, right? Wherever you are putting different CU, DU, all this, you can actually cluster them together. For example, individually you can control each DU, but then each DU, like let's say 3 DUs make up a CU, and that becomes your one single site. So that can be clustered together. So all such options are available. So we also have high availability deployments done on this, and a lot of performance analysis, KPIs, real-time analytics, such as MDT data. MDT stands for minimization of drive test. So you can actually configure a particular user for MDT, and you kind of get to know all the parameters with the location information about that user. So these kind of performance analysis, correlation analysis, predictive analysis, all this can be done offline, and real-time tracing can be done. Okay, so this is our EMS. We have a common EMS system which handles both our 4G and 5G nodes. Okay, so our ORAN deployment. So Leica primarily is targeting private 5G deployments. We are trying to target cases such as the railways, factory automation. In fact, in each of this, we have done customer trials, and some small deployments have already happened in most of these cases. So railways, factory automation, and then mining. So in mining, it's a special use case where you may have to have a different kind of channel there. So these lot of trials have been done, and some early deployments also have been done for these different use cases. So I'll just go to each use case. So this is basically a railways, Indian Railways, where we have done some early beta testing. So our 5G RAN solution is used for the railway network, and similarly we had already done it for 4G. So with the RDSO, so RDSO is the organization which performs the test and does an evaluation. So they have a list of test cases which you has to pass to get the deployment done. So we have already done the evaluation of this. So what is the spec? Okay, 700 megahertz band and 40 watt per antenna, and it actually is used for mission critical. This is not a 5G solution for customers or railway passengers. It is for control of the railway infrastructure, right, and mission critical communication between the railway operators. Okay, so this is another deployment use case where we have set up a private 5G network for data calls. This is done here in India already, and we have put our CUDU in it inside a building in a server room, and the RU is deployed on the rooftop. And we are able to do a complete coverage of the area, and we are able to show real-time data calls in our network, as well as we have integrated with the operator's legacy network. So the operator already has a legacy network, which is 4G, 3G. So our 5G network voice calls have to be routed to the operator network. So this is something we have now done. So this is again a 5G network for factory automation. So we have set up a private 5G network for assembly lines in the warehouse. So it is something which we have now started deploying. There are our radio units at various points in the factory, and so that there is a complete 5G coverage within the factory, and the spectrum which is used is completely going to be within the factory assembly line. So everything can be so it's a completely different deployment, not your terrestrial deployment. And there are specific devices connecting to our devices. So say for example, there is something called PLCs, controllers, screwdrivers. So these are very big devices, so they can be controlled using the 5G link. Earlier you had to draw cables, and maybe Wi-Fi is not so reliable in all the points, because Wi-Fi operates in unlicensed band, right? So what could happen sometimes is there will definitely be some sort of interference. But with 5G inside the factory, you will be able to replace any wired network with the same amount of reliability, which is achievable in wired mode. So it also has this high resolution 5G camera. It's basically a UE which has a camera inbuilt, and it actually does video analytics inbuilt. So it's actually good. It requires a dedicated spectrum. Okay. So that's it. And now I'm just going to what are the things which we are kind of going to do, or we are in the pipeline, and what we are working on. So one is massive MIMO. So today I showed you that we have 8x8 RU. So those are going to get upgraded to 64x64. So for this, a lot of hardware design, simulations is something which we do using software or emulators, and antenna prototyping is happening, and some real world tests to prove that we are able to get the massive MIMO streams working. So this is something which is going on. NTN. So NTN stands for non-terrestrial network. So this is something we had to have these air balloons or satellites. So your base station will be there on that, and your device will be on the ground in remote areas. For example, where there is no coverage, right? So in such kind of areas, your device will be there. Generally, these devices are like your IoT, right? So some sensors or something. So as the satellite passes, they will exchange data, and then when the satellite is not there, they will buffer the data, and again when the satellite coverage comes back, they again transmit. So this is what NTN is, and we had started this work quite long back. So we have signal propagation models which we have developed for this NTN environments. The scheduling and resource allocation, so which I told, right? We have to do some buffering. The scheduling is completely different for NTN as compared to your terrestrial networks. And primarily, the focus is on IoT solutions, which kind of come up, give you a small amount of data, and then go ahead, right? So the other thing which we are working on in the future is PTN. So positioning, tracking, and navigation. So this is a concept which in LTE there was a lot of traction, because see, positioning of the user is actually a very critical feature now coming in the future, right? So currently people are relying on GPS or your GNSS based technologies, but there are disadvantages that you don't get indoor penetration. There's a significant time in acquisition. But with LTE, there was something called LTE positioning, but in NR that is improved, and there is a protocol called NRPP. It stands for the NR positioning protocol, and using this, there are many methods, right? You can get OTDOA, which is a direction of arrival, and RTSD, which is actually a time difference between two different transmit points. So a lot of measurements you can get from the user, and you can use some trilateration techniques and angle of arrival and all this, and you can almost predict the precise location of the user. Now, obviously, once you derive the precise location of the user, the amount of applications is unlimited, right? You can do geofencing, you can do monitoring, tracking, everything which is possible. Now, if you multiply this positioning with your MMTC, right, your massive machine type communication, so each of your small device has its own positioning mechanism. So let's say you misplace some small product or something, you can precisely monitor its position. So think about it like each of your vehicle has a PTN, right? So you exactly know where is your vehicle. And you are not now depending on GPS and all that, right? Which suppose you go in a tunnel or under a underpass, so you will not get GPS. So all those problems are not there. So on this, we have done quite some work in LTE, but in 5G, we already have. We're looking forward, and there is a customer interaction for this. So some engagement is happening, and therefore we are focusing on this. Then coming to IAB, I think this is something all of you would have heard, integrated access backhaul. So basically, whatever you see as a backhaul, that used to be a wired link. Now, if you are doing deployments in rural areas or remote areas, having a wired connectivity is a challenge, right? So earlier for this, there were exclusive backhaul connectivity devices which would do this. But now with the IAB, what happens is your same device, the radio front end to the backhaul. Okay, so these are the things which we are working on actively. So this is something from our R&D team.